Welcome. Good morning, good afternoon. Thanks for joining us today. It's a pleasure to welcome you once again for a new webinar about solar in Africa, of course, because you know this is what we do. Thanks to all those who were already joining a few minutes ago, and thank you for those of you who are joining just now. I'm very excited to be holding this event because it's a very popular topic, a potentially very big business opportunity for all of us in the solar industry in Africa. And we have got an amazing lineup of experts today who are going to share with us a little bit about their expertise on floating solar, not only in Africa, but also globally. And so really, I would like to already thank you for accepting the invitation and for sharing your knowledge with us today. Before I hand over to our moderator of the day, I'd like to do a very quick little housekeeping reminder. You know, if you are following us on regular basis, yes, of course, the full presentations as well as today's recording will be shared with you after the event. So no need to stress if one slide went a little bit too fast, if you're missing some details on the slide, they will be shared with you later. And so you can focus on our presenters today. And then the second housekeeping item that I would like to share with you is how to make the best use of the functions of the Zoom session here today. At the bottom of your screen, you have some controls and you have several options. Function, I see some people are already using it, and this is great. This is ideal if you want to connect with other listeners, to tell them which country you're from, which country you're dialing in from, and really connect the network. But please, if you want to submit a question to one of our presenters today, please do so through the Q&A option. It's just a lot easier for our moderator to skim through all the questions we will be receiving, and it also makes sure that don't get to address your question today, we will get a chance to follow up with you individually after the event. So please don't miss this chance and make good use of the two options. This is it for me. I've spoken enough, so I already want to hand over to our moderator of the day, Raúl. Raúl is calling us from Hamburg today. Thank you so much for accepting the difficult task of moderating, but I'm sure you'll do an amazing job because literally floating PV is a little bit of your life, at least for the last 10 years. You've been spending this time on project management and specifically on floating PV plus site characterization for renewable energy projects in Africa, but also in other parts of the world. You are representing the company Dornier, which I believe you will tell us a little bit more about for those listeners who might not know the company yet. And it's really, I'm super happy that you have accepted this invitation, and I'm gladly handing over to you now. Thank you.
Thank you very much, John. And I think the pleasure is mine. And the moderator role, I think it's really easy to handle with such a line of experts. Thank you, Susan. Thank you, Sergio, Paul, and Henry to be part of this one. And if I may ask John to confirm that you are seeing the presentation.
Yes, it's coming now. You can just put it in presentation mode.
Excellent.
Everything will be good.
Thank you very much, John. As has been said before, so I'm working with Dornier Suntrace. We are a company that is working since the last at least 5 years within the topic of floating PV. We have also seen more of a boom, but we don't come isolated from this part. So we have been working in several other areas. Specifically, we're part of the Dornier group. where 5 business units are actually in place, whereas Dornier Suntrace is part of the renewable ones. And we have been active within the Dornier group almost around the world and in several countries. So we are a company that is established in 2009 in Hamburg, as John mentioned. We are quite an international team, in average very young, I must say. But we have all the aspects covering within the different countries, nationalities, and continents. We have been engaging in several projects, mainly focusing on solar, both PV and concentrated solar power, and recently also working together with other of our members in other renewable energy technologies. And within the expertise within solar PV, we have been working in floating PV in several aspects. Overall, we have more or less 10 gigawatt in solar projects, more than 200 projects in different countries, 50 countries at least, and we offer solutions in the different aspects and steps of the project management development. As you can see in the map, we are quite spread from the upper the tropics, then down to the upper and southern hemisphere, and focusing on several countries, having offices within the Dornier group, within Germany, India, South Africa, Ukraine, Kazakhstan, Saudi Arabia, and India, among others. And as you can see in the countries highlighted there, countries where we have actually supported on floating PV. Overall, I mean, honored also to be part of this moderation part, and we are very happy to have been selected as Technical Advisor of the Year from Asia. So thank you very much for that recognition. Back in 2020, quite a challenging year, as you might recall. And the reason why is because we have been quite active within the African country, supporting not only IFIs, but also private clients in several projects, not only related to floating, which is the topic that we are talking today, but actually focusing on several project implementation in areas of where the our consultancy services has taken up one step forward. Some credential here, I will not go into deep. I would rather have the privilege to have the other speakers talking about the on-site experiences, but you can see that we have several floating PV projects ongoing, where I am participating in every one of them. Not maybe sometimes the project itself is requires challenges from other aspects, but we have noticed that floating PV, the trend that has been shown in the implementation of different tasks, is not just a coincidence. So floating PV industry has grown in the last decade constantly. There has not been any year of contraction, and actually we have reached more than 3 gigawatt installed capacity by last year, by the statistics that we have on last year. As you can see in the trend, most of the development is based in China. In solar in general, that's the big trend. And most of the initial developers were in East Asia, with some exception, for instance, as in Europe, from the Netherlands, where most of the development has been focusing on near and offshore. I would like to jump, I would like to jump to the fact to say that this is, in the implementation of the floating PV, is not a region-specific topic. Rather, it's more towards the implementation of usage of that portion of area within our globe, which is covered by water, which is not only a precious resource, but actually it's a matter of the co-location and co-usage of the same area for of different benefits and aspects. And the main reason of the implementation of floating PV within the different countries has been to improve the positive effect of having an improvement in the energy yield due to the cooling effect of the floating, in this case, the PV infrastructure. As you know, the cooler a PV module is, the better it performs. Heat, although the resource is solar, heat is actually a counter effect on the yield production. And that's why new opportunities has been developing floating PV to scale up the generation of solar power and its installed capacity, especially in places of high population where the land usage is reduced. And also elimination of major site preparation, because the reservoir itself, the structure is floating, and there's some improvement in the water quality due to the decrease of algae growth. Of course, there's in countries where the evaporation is a big issue, we have the additional benefit of covering or reducing the area where the sunlight actually creates further evaporation in the reservoirs itself. And of course, the coexistence with other water activities, for instance, fisheries or similar. Before giving the word to the panelists and start with this impressive team of lineup of experts that I'm going to discuss, I would like just to highlight where floating PV is heading based on the trends that we have seen as up to now. Floating PV is mainly could be focusing on freshwater or saline environments, marine environments, where freshwater development has been gone quite in a good rhythm. Most of the over 100 megawatt projects has been developed, has been in freshwater. And within the marine environment, near shore is where the most of the projects are currently ongoing, and offshore is more actually is starting to go into the commercial part. So we have seen some offshore examples, some 2 manufacturers that have survived at least 1 or 2 winters in the North Sea, north of Europe, which is quite a strange conditions. Where we have also seen that there's a freshwater project going over the 100 megawatt capacity. And last but not least, nearshore, actually several projects that we are working at the moment has already more than 100 kilowatt peak examples, and that is a trend that will keep on going. That being said, I will ask John if you can allow me to show our next moderator. In this case, I'm glad to present Sergio. Sergio, he is the head of renewable energy and at Global Tech, and he has more than 7 years of experience actually working Global Tech in several projects, owning more or less 50% or more than 50% of the floating PV plants in Spain, and has a personal mission to go and export the technology towards Africa for the implementation of greater solar potential. He's a master in civil engineering, and I'm glad to give you the word. Please, Sergio.
Thank you, Raúl. I'm going to share with everyone. Okay. First of all, I would like to thank AXIA team to invite me to this webinar. It is a great pleasure for me to share my knowledge of floating PV system and to help make this technology known. First of all, I would like to make a brief presentation of my company, Global Tech. It's a 15 years old Spanish company dedicated to management implementation of EPC projects in renewable energies, among others. Global Tech core business is focused in sub-Saharan Africa, with offices in Madrid, in Spain, in Luanda, Angola, and in Maputo, Mozambique. Since early 2020, Global has participated in more than half of the whole megawatt installed in floating PV in Spain, which means more than 6 megawatts.
May I, sorry, interrupt you. The presentation just stopped from your side, maybe. I'm so sorry.
Please reshare it, Sergio.
Please share the screen. That would be great.
Okay.
Yes. That's okay. Thank you.
Perfect. I just seen currently we aim to export our know-how developed here in Spain to our core business in Africa. Just briefly presentation of what is photovoltaic PV floating system based on the same principle and with the same basic equipment as a traditional photovoltaic plants. Floating PV infrastructures consist of a very simple system. It's just putting on water the floaters, which consist in an HDPE structure that supports the PV modules. And then the most important thing, the mooring and anchoring system that controls the movement of the floating structure. In the following infographic scheme, you can have an idea what a floating PV system is. Just a second, just to see what's this, everything composed the PV floating system. And then there are many advantages that Raúl has commented before, so I'm going to go briefly. We know free land for energy production, which avoids all the obstacles of land acquisitions. Improve, as Raúl said, energy efficiency due to the cooling of the water on the modules. The production efficiency rises between 7 and 11%. Of course, water savings. The installation of floating PV covers the surface water, and this allows to reduce the evaporation of water, which can reach an 80% of savings. Quickly implementation. As we don't have a fixed structure, just floaters, the installation is similar as do a puzzle. Okay. And of course, reduce maintenance on water bodies. The amount of dust and vegetation is lower, so costs and timing is going to be reduced. And then I would like to go in detail with, for us, the most important advantage here in Africa. That is the synergy with electric infrastructure. I would like to share with you a potential opportunity for Africa. And this is the possibility of an interconnection of a floating PV system with an existing hydroelectric installation. It makes sense location with weak network. The great value of this hybridization is to take advantage of an existing connected infrastructure. It saves a lot of cost. Same time, it compensates the uninstalled energy output. Following recent studies from European Commission, this hybridization could increase annual production of these plants around 50%. This last slide is just to share with you some numbers. I think that may help you to have an idea of FPV advantages. So, for example, adaptivity. It is a system that supports important water oscillations. And this is a really interesting feature in locations with high wet seasons. It supports variations up to 50 meters. Installation, as I do, really fast. We can think about an average of 1 megawatt is installed in 15 days and could be faster. Of course, respectful with nature, demonstrate with international certifications, and resistant to climate conditions. System could be redesigned for 280 kilometers per hour wind speeds, proving in Asia, as Raúl told, it's a continent which a great expertise in floating PV that suffers a lot of typhoons during the year. And responding one of the questions of this webinar, the additional installation costs of FPV compared to traditional PV are clearly absorbed by all the elements I have already commented. To sum up, water evaporation savings. Here in Spain, 1 megawatt means around 8,500 cubic meters per year of water savings. Free acquisition, saving in solar tracking systems. Solar tracking means almost 20% of capex in traditional PV systems. Saving in installation times, remember 1 megawatt about 15 days. And of course, if we connect with an hydroelectric plant, we will take the advantage of an existing evacuation system already installed. And I hope I comply with the timing, Raúl. Thank you very much.
Actually, very well. Thank you very much, Sergio. That being said, thank you for doing these opportunities, and it's important to highlight about the environmental aspects. Together with that, the savings in water and the relocation of the cost within among the other aspects. I would like, in the meantime, John, if you can please share the slide. Thank you. We are moving now to Henry. So Henry Njiwa, he's a sales manager West Africa for JA Solar, and he has more than 8 years experience within the renewable energy industry, and it started with EPC companies and now is moving towards engineering technical business, and recently made a switch to an O&M company in this case, and holds an MBA in sustainable energy and has a certified project management part. So Henry, I'm happy to hear from your experiences from the OEM part. So please feel free to continue. We can, if you can activate the microphone and share the screen, that would be great.
So just a second, I'll just try and share my screen.
Yes. Excellent. We can see it. If you can go to presentation mode, that would be appreciated. Thank you.
All right, thanks for the introduction, and welcome everyone, and thanks for taking time to join this webinar. It's always a great thing to have an opportunity to contribute and then also discuss the various opportunities we have as regards to solar PV across Africa and in the world in general. So just a brief introduction about myself. So my name is Henry Ejunwa, and then I am the sales manager for JA Solar, covering the West and Central Africa region. So I'll just do a brief introduction about JA and then move to our key focus area, which is floating PV, and then the opportunities and then the challenges that we have during. So JA Solar as a company started up in 2005. Major focus was to manufacture silicon wafers and then cells. And then at about 2009, we progressed to manufacturing our own solar modules ourselves. And then since 2009 to date, we've done a global shipment of over 103 gigawatts cumulatively globally, and we're currently ranked number 2 in terms of global shipment, and then we have 14% global market shares. We have quite a number of employees coded across the world. So this just shows a range of our products. It ranges from getting the silicon ingots down to the wafers, the cell, couple of plants that we have collaborated with core EPCs to deploy for those projects. We have about 10 manufacturing plants spread out across China, and then we have one based out in Vietnam. Then just to go back a little bit. So at the moment, we have a module manufacturing capacity of about 75 gigawatt, and then for wafers and cell, we have about 60 gigawatt manufacturing capacity. So at the moment, this is our 3 range of products, Deep Blue 3.0, 3.0 Pro, and then 4.0. The Deep Blue 3.0 is just an upgraded version of the 3.0. Basically, we implemented a patented technology, GFI, and gapless flexible interconnects. So with this technology, we're able to reduce the space between each of the cells. By doing so, we with the same square area, we're able to achieve about 20 extra wattage for the panels. This is just driving towards being more efficient in terms of the modules that we deliver to the markets. So with the same square area, instead of, if you look at for the residential, so for each of the range of products, we have the residential, utility scale, and then also CNI. So we can see from 415 for DB 3.0, moving to 3.0 Pro, we scaled it up. It started from 420, ranging upwards. So we can see it across the three different range for the 3.0. The 4.0 being the most latest technology, which is the N-type technology. GA Solar has its own patented method for creating the N-type technology, which is what we refer to as Bisium technology. So we also have this spread out across residential, 435 watts, and then also for CNI space, 575 watt, and then for utility scale, 625. The N-type is basically all manufactured as bifacial modules, because at the end of the day, you're trying to be more efficient in the modules you're deploying into the market. So now, moving slightly away from what we do as JA, moving into the main topic for the day, floating PV. We supplied the very first floating PV project in West Africa, which is the project for the Bio Authority. So it's scaled for 5 megawatts, but we've just been able to supply 1 megawatt, and then progressively it will be scaled up until 5 megawatts. So this particular solar installation feeds into the hydro outputs for the Ghana VRA Authority. So I'll just try. I know we have quite a lot of experienced professionals here when it comes to floating PV, but then these are just few facts that I wanted to share with us as regards to floating PV across Africa. So basically, we all understand that taking an example for the floating PV we already have for Ghana, it was done at the hydro dam. So we can realize that if we take all the reservoirs we have across Africa, and then we have floating PVs on each and every one of them, we have a capacity to be able to generate about 2,922 gigawatts of added solar capacity. So that shows a lot of prospect in terms of floating PV. And even if it's just about 1% that we're able to cover, we're also able to double the capacity of Africa's available power. And then, like we also know, across Africa, hydro dams seems to be the largest source of renewable energy opportunities that we have currently in Africa. So if we take the advantage of the reservoirs and then we have a lot of floating PVs across them, it gives us an opportunity to scale up power generation across Africa. Then a little bit of slight advantages and then the disadvantages of floating PV. With floating PV, we don't run at a loss of having run out of land. I quite understand that Africa quite has enough arable land, but when you go into floating PV, you can make use of the land for other activities while making use of the hydro reservoirs, which are actually not doing anything. But a slight disadvantage would be that it comes with an increased cost due to the specialized mounting structure. But then also, so this is me just switching between advantages and disadvantages, not necessarily in any order. So it also compensates for the hydropower production, meaning you're able to double the usage of the hydro reservoir. So aside just being able to provide hydropower, you're also making use of that same reservoir to also generate electricity via the floating PV. Then when you have floating PV, like the last presenter also rightly mentioned, it minimizes the evaporation you have from the hydro reservoir. So meaning you have more hydro energy at the end of the day. Then it also helps, just also like the previous presenter, it also helps in terms of cooling the solar cells. So you are not necessarily, like we all know, PV modules are quite affected by temperature, because that's why all PV modules have a temperature coefficient. So with it having from the hydro reservoir, so that also is an added advantage to the system. Then also, as compared to ground-mounted system, when you have a ground-mounted system, you have quite a challenge when it comes to being able to connect the output to maybe if you're feeding into the grid. So at some point, you might have to do some transmission lines, some step up and all of that. But with the floating PV, there's always that possibility of being very close to the tie point of the output side of the hydropower system. So making it quite easy for you to just do the interconnection. So this is just a global map in terms of Africa, just showing points where we have considerable hydro reservoirs, and scaling up from the number 1 to up to the number 20. In terms of the surface areas that we have, just shows the amount of opportunities that we have when it comes to floating PV. Okay, so thank you very much, everyone, and I'll just hand the mic.
Thank you very much, Henry. Meanwhile, the next presenter is shown. I would like to also to highlight what you mentioned, is that in terms of the application of the potential of how much floating PV can be applied within the different countries that we have based on the needs, is that there's already an infrastructure of reservoirs, either to hydropower or to irrigation, or actually for water treatment, that can be used for these aspects. So in this fact, I would like to kindly introduce Suzanne Kirie. She is a country manager in Kenya for Ecolingo. She has more than 10 years experience in renewable energies and telecoms. Actually, as mentioned before, she has been working at Ecolingo as country manager, holds an MBA in strategic management, and has a track record in project management for FMCG and other industrial services. So please, Suzanne, happy to hear from you. Feel free to open up the microphone and share the screen. Thank you.
Thank you so much, Raúl. Thank you to the other panelists and also attendees of the webinar. So always happy to share and interact in these renewable energy topics, and very happy to be here today to discuss on floating solar PV systems in Africa. So I will share my screen and give a brief introduction of the company and what we've done in terms of implementation of floating solar PV in Kenya.
Yes, thank you.
Yeah, so let me know if you can see my screen.
We can see it now. If you can go to presentation mode, that would be great. Thank you.
Great. So I'll just start off with a quick introduction on who we are. So Ecolingo is a global energy as a service provider. We were founded in 2016, headquartered in Berlin, with various offices across the globe. So we have offices in Ghana, Nairobi, Kenya, where I sit and head overseeing the East African region, offices in Chile, offices in Vietnam, Bangkok, and recently opened an office in Uganda. Regions of activity, as mentioned earlier, include the Sub-Saharan African region, Southern Africa, Central America, South America, and Southeast Asia. We have over 30 employees cutting across 18 nationalities, with 45% of them being female. And we have a track record of 102 projects with more than actually 80 megawatt of projects built globally. So we pride ourselves in leading in the clean energy transition around the world, and we help, or rather contribute to the fight against climate change. I'll go to the next slide. So in terms of the floating solar PV, maybe I'll just give an introduction on this. Sorry. So for floating solar is a solar PV installed on a structure on floating water, example, a sea or a dam, and it has to be installed in calm water bodies. And we've seen that floating solar has opened new opportunities for scaling up solar generating capacity in various markets, especially in areas with high population density and areas where there may be issues with availability of land. So we find that floating solar PV becomes a viable solution for implementation. So advantages of floating floating solar, as earlier alluded by Paul and Sergio, Raúl and Sergio, it improves efficiency, saves on land space. There's also reduced water evaporation from water reservoirs, as the solar panels, they provide shade. Improvements in water quality through decreased algae growth, reduction or elimination of the shading of panels by their surroundings. There's also elimination of the need for major site preparation, which we know takes time, especially when you're doing the normal conventional either ground mount systems or rooftop systems. Then there's easy installation and deployment in sites with low anchoring and mooring requirements, and this leads to faster installations. So this is just a pictorial of how floating solar PV works, which I'm sure the other panelists have also showcased on some of the maybe implementations that have been done globally. And then just here to mention some of the floating solar providers that we have. There's NP Solar, there's Isigena, I think this is Spanish, and I've seen they're also with us here. There's Ciel and Ter. There's Solar Ants floating PV systems, there's SwimSol, there's ProFloating, there's Solar EastFloat, and there's SunFloat. This is just to give an overview of some of the floating solar providers that we have globally. Then in terms of technology, which has also been discussed by the other panelists, is that floating solar technology is produced through a blow molding process. Then the equipment is qualified through a technical test to make it safe and long lasting, which is very key and critical for such PV systems. Then the general layout of the floating solar is similar to that of a ground mount system, only that the PV arrays are normally mounted on a floating structure. Then the floating solar technology has a rapid growth in solar markets, which we've seen that from 2016 when this was adopted. And the first 20 plants were built between 2008 and 2014. And we've seen even more larger and bigger floating solar PV plants being implemented globally. Then floating PV systems, they consist of modular floaters assembled in rows made from recyclable HDPEs. Then you see that these systems support PV modules above the water while withstanding long-term environmental hazards like heavy rains, winds, and snow. And there's a pictorial of how a typical implementation is done that we've showcased here. And then in terms of the technology features for such systems, they have to have extreme wind resistance. Such systems can withstand up to 210 kilometers per hour winds. Projects can be specifically studied and adapted to deliver high system wind resistance, again, which I've mentioned is very key. Then there's drinking water compliance. Systems are made with eco-friendly components, preserving the originality quality of the water that the systems are built on. Then there's anti-UV corrosion treatment. The systems are designed to be highly resistant to UV corrosion for more than 20 years. And then safe mounting and maintenance. They are designed to be simply and quickly implemented with easy access to the modules for maintaining and cleaning. And I'll also mention on the floating solar system, which is a first of its kind in Kenya, that Ecolegal, together with their EPC partner Technoelectric, implemented in the Rift Valley. This is in Naivasha for Rift Valley Roses. So the project is actually a 69 kilowatt peak system, which is definitely a floating system. And we installed 216 panels, a panel capacity of 320 watt peak by solar watt, and the inverters by Kako, and the mounting system by our partners Isigena, who are with us today. And these are some of the partners that actually made this first of a kind project successful. Technoelectric, then there's the German agency DENA. Implemented as part of the DENA Renewable Energy Solutions Program, which was initiated by DENA, as I've mentioned, and supported by the Federal Ministry of Economics and Energy. And it was a very interesting project, I would say, first of its kind. And I would say Coligo paved way for other providers actually to implement floating solar projects in Kenya. And from this project, we've received a lot of requests from various companies or various organizations within the commercial and industrial space to actually implement with an interest to, wanting to implement such a system. So this is about our client. This is RVR, or Rift Valley Roses, 69 kilowatt peak solar system installed in the water reservoir at RVR farm in Naivasha, Kenya, where we already have a 75 kilowatt peak system roof system, which has been in operation since 2018. Then for the tourism and agriculture clients, such as flower farms, this is actually a perfect fit for such systems, where the customer has a water body that is available and we can make use of. Citing that cost of system is competitive with ground systems. I'm sure such systems are seen to be a bit costly, definitely, than ground or roof mounted systems, but they tend to be competitive in terms of resources for implementation. Then we have additional savings by reducing evaporation, as well as limitation of algae growth.
Susan,
so,
if I may kindly ask you to reach a conclusion.
Yes, so I will just maybe quickly state the implementation. With less than 24 hours, the project was financed in our crowd investment platform. And then we know COVID happened, so we had a bit of longer lead times, travel restrictions. And then once we had all the components in country, there was a quick and smooth installation that was done at the site. And in terms of operation, the 69 kilowatt peak system supplies alone up to 30% of the farm's electricity demand, saving 1,355 tons of CO2 during the system lifetime. And then just highlighting that these such systems are unique for clients with water bodies, and it adds up to a step in fighting against climate change. So thank you. That is my presentation, and over to you, Raúl.
Thank you very much, Susan. So meanwhile, the next presenter is shown. I would like to also to highlight what you mentioned is in terms of the application of project. It doesn't have to be it started with several megawatts of project actually to be implemented. Rather, it's just supplying the need of power locally, which is a good implementation of not only water usage, but also power needs locally, so mini grids and similar. I'm glad to present Paul Kotze, just founder and managing director of Solar Energy Architects. He has more than 5 years experience in solar industry. He's, as mentioned before, founder and managing director of Solar Energy Architects since 2015, has seen 30 megawatt of ground-mounted, rooftop-mounted, and floating PV plants, where also 10 megawatt hour energy storage has been already implemented. He's a mechanical engineer, and I'm happy to give you now the microphone. Kindly share your screen, and please tell us a little bit about your experience in floating PV.
Well, thank you very much for the introduction and for moderating this webinar. I'll just share my screen with you. Raúl, can you see my screen?
Yes.
Fantastic.
Thank you.
Yeah, and thanks to AFCIA for the opportunity to be on this panel and share our experience in the South African market. And yeah, and thanks for the amazing work you're doing for solar in Africa. Yeah, so Solar Energy Architects is a bespoke project developer based in Cape Town, South Africa. We take a very unique and client-focused approach, and I think we can provide a unique perspective today because we work closer on ground level, smaller types of projects, and specifically in the behind the meter space. Right. So we're based in South Africa. Most of our projects is in South Africa. We do the full project suite, turnkey suite for our clients, from concept and viability to operations and maintenance. And we've got various financing options available. We work with worldwide finance partners to bring any type of project to reality. So I think most of the other panelists have explained quite well, all the advantages and disadvantages of floating solar. The land availability is not as problematic in South Africa as it is in other regions. So the increase, or the perceived increase in capital costs or capital outlay costs is a factor driving clients rather towards land-based systems than floating systems. That's at least that is our experience. There's a few large water bodies available in South Africa, so the tendency is for in the private market rather to focus on smaller water bodies. Yeah, and those are the clients that's participating in this space. Yeah, so obviously the smaller projects comes with unique challenges. One of the big challenges is it drives up the costs, specifically the logistics costs, importing, freight, and also minimum order quantities. So it's very few suppliers that will deliver the small quantities that's sometimes required for smaller projects. And unfortunately, we have no local manufacturing in South Africa, so that also obviously drives up the cost. So if there's any suppliers on this webinar that wants to start manufacturing locally, please do come to South Africa, because I think there is definitely some opportunity. Yeah, so we in our space, the behind the meter space, smaller projects where we're seeing a lot of growth and requests coming in is on the agricultural side specific. There's a lot of synergy between agriculture and floating solar PV. Also in mine reclamation. Yeah, and we get very, very high yields in South Africa in our experience, and also the water evaporation savings component is also a lot higher than what we've seen for instance, in the Spanish market. So yeah, we've got some good opportunities here in South Africa. We need a little bit more local adoption, but we're trying hard and driving the process to get the clients in the project to fruition. That's all I'm going to add from my side, Raúl.
Excellent. Thank you very much, Paul. Before opening up the Q&A session, I would like to highlight what you mentioned, which is the economics of scale in logistics and import and export from different countries. It's quite accurate what you mentioned, that in some implications on the quantities, when quantities is the big question, the prices for the implementation of such systems has been seen the need of having some kind of co-support from not only a private developer, but actually in line with other projects which are aligned to this, and reduces the necessity for such high prices, or what you mentioned, also try to get into the production within nearby countries, which is I think it's a good idea, a great idea, just not only on the social benefit, but actually on reducing the immediate carbon footprint for exporting such a big amount of resources. Then I will start with or open up the Q&A session, and we have had several questions actually dropped there, which the team has taken the time just to go through them and allocated them within the different from the chat up to the Q&A session. So we have several ones, and which it has been a little bit difficult, general ones first. So there's a question from Luke. if there is any environmental concerns to take into account within the when installing such systems. And besides that, I would like to add also another part which is mentioned there, specific to these aspects. If there's any, while the co-location, if there's any other effect from the floating PV in the water quality of the aspects. So I would like to open this question to all the speakers. You mentioned in this case Sergio and also Susan on this aspect. So feel free also to add to this question. So if there's any concerns that you have experience within the implementation of the projects that you would like to highlight.
Okay, Susan, I'm going to start, and then if you want, you can correct me.
Okay.
About it's important, of course, the climate conditions for this kind of installations. As I told, wind speeds is really important. Of course, the type of pond of the basin, the orographic conditions, the geographical conditions. It's really, really important, the type of soil. So there are different systems that fit depending on the soil conditions. No? And going through quality of water, as I told you in my presentation, there are few certifications that demonstrate that this kind of HDPE floaters don't affect the quality of water. Indeed, there are here in Spain some entities that are starting to install this kind of floating PV systems on wastewater treatment plants.
Excellent. Thank you very much for the question. Susan, please, if you would like to add on.
Yeah, I think Sergio has said it very well, and I think maybe major challenges that are normally faced when installing such systems are the environmental conditions. So this is very key to audit before implementation of such a system, as well as maybe checking on the alkalinity or salinity of the water body, because of course there are these factors like if there's salt water, it can contribute to corrosion of most of the components. So it's normally very key to ascertain and audit levels of salt, if any, in the water, because such really influence even how long the plant or the system can actually last.
Excellent. Thank you very much, Susan and Sergio. I would like then to change a little bit the topic of the QA of the questions, and moving from the environmental towards the actual implementation in terms of costs, just to cover some questions at the same time. And in this case, I would like to ask both Henry and Paul to mention over here. So there's several questions, and most of them are actually quite specific in terms of if we can give a guide, how much is the expected cost in US dollars per megawatt peak across the different capabilities, but also questions asking, for instance, if there's any specific reference on the cost in terms of the yield that the system can be withstanding. And one additional question to this regarding how does these issues of implementing such projects in African countries can be reduced in terms of the risk and the challenges of implementing these kind of technologies, being the cost one of the biggest? I don't know, Henry or Paul, who would like to start? Paul, you have the open microphone,
first.
please. Yeah.
Yeah. Okay.
Over to you, Henry.
Please, Henry, from the OEM.
Okay.
On the part of the supply.
Yes. Okay, so I'll just chip in a bit and I'll allow Paul ride on. So being a floating PV, you don't have quite a lot of old existing installations where you can say you want to pull out data from and analyze what the cost per kilowatt peak and all of that will be as compared to if you don't do floating PV. But one thing I know for sure is when you're doing a ground-mounted installation, you're also factoring the cost of acquiring the land. So if you do, what I would say is when you're doing, when you're either going for floating PV or going for a ground-mounted, you have to do a proper cost analysis to understand the extra cost you're getting, you're committing to getting the mounting structure as compared to getting the land for the ground-mounted system. So there has to be some sensible cost savings if you're going for floating PV. And then also, like I said, there's not so much data, but what we do know is for a certainty, there's a help the water does in terms of reducing in cooling the cells. So we don't have the data that we can reference and say, okay, the water cools the cells by so percentage, and by that you're able to get more energy and all of that. We just have an installation of just less than 1 year. But I am 100% sure that the cooling effect will definitely have a positive effect in terms of the annual energy generated from your installation.
Excellent. Thank you very much, Henry.
I want to tie in with what Henry's touched on, and so the problem we're facing is that funders are not always keen to approach these kind of projects, specifically due to that increase in yield that you're getting due to the cooler panels. It's a very difficult measure to get right up front, and it has a substantial impact on the long-term cost, or long-term feasibility of these projects. So that's something that's difficult. There's been some inroads that's been made on those type of simulations and estimations, but we're struggling to see funder adoption on our side with floating PV plants. And yeah, Raúl, just to briefly touch on the cost side. So the retail cost side, we are selling these projects at the moment in dollar-based values is at $1.11 per watt peak. So it becomes expensive.
Excellent. Yeah, I totally agree in that regard, Paul. Thank you very much, Henry and Paul, for this one. Taking advantage of the time, we have 2 minutes plus a little bit plus minus buffer. I would like to open up this question more towards the general. So feel free, any of the speakers, to add on your specific experience on this, which is the actual risk and impact of the application of floating PV within the areas that you have covered. So most of you have covered floating PV and freshwater. Could every one of you maybe shortly, in half a minute maybe, highlight what was the risk, the biggest risk or the biggest impact that you had to mitigate in terms of the impact and reduce in terms of the risk for the projects that you have implemented? Please, Sergio, Suzanne, Henry, and Paul, feel free to add on.
Raúl, I'm happy to go first. The biggest risk for us was the lack of experience and the lack of the labor experience to do these type of installations. So our biggest mitigating factor, way to mitigate this was to get a lot of online training on how to actually install these types of plants. And obviously this all happened during COVID, so it was a little bit difficult, but yeah, we managed well. But for us, that was one of our greater risks, kind of health and safety related wise, and yeah, installation wise.
Excellent, thank you, Paul.
So to also further buttress on what Paul just said, the lack of experience. So which was one of the reasons why when a customer wanted to deploy more logical sense to go with it in batches. So, which is one of the reasons why they went with just 1 megawatt, then study it over time, maybe a couple of 12 months or 6 months or thereabout. Then we can learn, pick some lessons from there, and that advances what we do for the next batch, for the next phase of installation. So I think for a fact, the lack of experience is also a big issue.
Thank you, Henry. Susan, please.
Yes, so I would, I think, add to what Henry and Paula said. Maybe lack of experience was a challenge. However, I mean, for us to have RVR as a success project, we worked with one of our qualified EPC partner who had experience in building such systems, the floating solar PV. And we also faced it because we did the 69 kilowatt peak as a phase 1. And now the customer is coming back wanting another phase, like a phase 2 of the project. So maybe main challenge that I envision many financials and maybe many implementation partners is the challenge of the technical experience in building such systems, and operations and maintenance as well, because it's a bit different from the traditional conventional maintenance of roof mount and ground mounted systems.
Totally true. I cannot agree more. Thank you very much, Susan. Lastly, Sergio.
From my point of view, the risk I see is the design, as in any installation, no? Which is very related to the lack of experiences, as Paul says. I don't see any differential risk to another installation. Thank you.
Excellent. Thank you very much, Sergio. And with that one, I would like to clarify to all other participants that your questions are really interesting. I have been reading them through, but due to time, we cannot answer all of them live. We are going to, as John mentioned, we are going to distribute this question among all the speakers, especially to answer those within the live stream. Cannot be answered within the live stream, sorry. Personally, I would like to thank you, Susan, Sergio, Paul, Henry. Again, we have learned a lot about your experience. I'm really happy to see that such engagement is actually ongoing, not only on the big scale, but on small scale and in different countries with different experience, and actually sharing most of them among you with participants. Most likely this kind of interest, you will agree with me, it will not stop in this year or in the next 2 to 5 years, but actually will grow up even higher. Thank you very much. I would like to give back again the ownership of this moderation to John. Thank you very much for having me here. If you would like to conclude.
Yes. Thank you so much. Thanks to you, Raúl, and our panelists today. I must make a revelation. This is the first time that we've received so many questions in a webinar and so many comments in the chat. I'm really impressed and happy, because that shows that this topic is so interesting to so many people, and among the people listening in today, many of them see opportunities and great potential with this technology. I'm going to close the webinar in a few moments, but I'm going to leave it open for a little bit longer for the people who want to chat further. And it's quite amazing. I've seen messages about, I am having a project, I'm looking for technology. I've seen messages, I have technology, I can help you manufacture locally. I've seen messages about, I'm looking to finance floating solar projects in the chat box. So very busy chat today, and I'm super happy, because this is really one of the goals for us at APSIA. It's to create platforms for professionals to connect. Everybody has something to offer, everybody has something that they are looking for, and we are happy to be the humble connector between all parties and help everybody to do more business, because in the end, that's what makes the most sustainability. So with this, I would like to conclude. Thank you once again to you, Raúl, to all our presenters, but also to all our listeners who took an hour away from their busy schedule to join us and to listen to what we had to share about floating solar in Africa. I must make a revelation. This is the first time that we've received so many questions in a webinar and so many comments in the chat. I'm really, really impressed and happy, because that shows that this topic is so interesting to so many people, and that among the people listening in today, many of them see opportunities and great potential with this technology. I'm going to close the webinar in a few moments, but I'm going to leave it open for a little bit longer for the people who want to chat further. And it's quite amazing. I've seen messages about, I am having a project, I'm looking for technology. I've seen messages, I have technology, I can help you manufacture locally. I've seen messages about, I'm looking to finance floating solar projects in the chat box. So very, very busy chat today. And I'm super, super happy, because this is really one of the goals for us at ABSIA. It's to create platforms for professionals to connect. Everybody has something to offer. Everybody has something that they are looking for. And we are happy to be the humble connector between all parties and help everybody to do more business. Because in the end, that's what makes the most sustainability. So with this, I would like to conclude. Thank you once again to you, Raúl, to all our presenters, but also to all our listeners who took an hour away from their busy schedule to join us and to listen to what we had to share about floating solar in Africa. Thank you so much, and I wish you an excellent rest of the day.
Excellent. Thank you very much.